review sheet, see logarithms and e to the x. The questions in this video are not the same as those on the review sheet, but if you work your way through the video, it should help you with the review sheet. So the first type is solving equations, and ones like ln of 4x plus 2 equals 7. All you need to do here is remember that ln is the opposite of doing e to the power of, so instead of ln 4x plus 2 equals 7, you can write down 4x plus 2 equals e to the power of 7. And then it's just rearranging it. 4x equals e to 7 minus 2, so x is e to 7 minus 2 over 4. The next one is just doing the inverse the other way around. So you get 3x minus 5 is equal to ln of 8, and then rearrange that. 3x is ln 8 add 5, and x is 1/3 of that, or you could write it as ln 8 plus 5 all over 3. If you have ln of something equals ln of something else, you can just get rid of the ln's. So you're left with 3x plus 1 equals 5x minus 7. That gives you 8 is 2x, so x is 4. However, always check the x equals 4 back in here, because you're not allowed ln's of negative numbers. And so if you put x equals 4 in, it actually works okay, because you get ln of 13 equals ln of 13, and that's fine. But if you've got a ln of a negative number here, then the answer would not be correct. The next type is to use y equals e to the x, which means you need to find what this is in terms of y. So if y is e to the x, then e to the 2x is equal to e to the x all squared, and therefore that is y squared, and 3 lots of it is 3y squared. So this now becomes 3y squared equals y add 2. Rearrange it, equals to 0, gives you y equals 1 or y equals minus 2/3. Now we slot them back in. E to the x is 1 or minus 2/3. You may realise at this stage that e to the x can't be minus 2/3 because e to the x is never negative. But if you don't spot it, just go through as normal and take logs. X is ln 1, which is 0, or you get x is ln of minus 2/3, and as I said a bit earlier, you can't have logs of negative numbers, so that one you need to get rid of. Logs of negative numbers are not defined, so the only answer you're allowed is x equals 0. The next type, sketching graphs and finding the range. To sketch them, the easiest way is to build them in stages. So for y equals e to the 2x plus 1, do y equals e to the x, then y equals e to the 2x, then y equals e to the 2x plus 1. It doesn't take very long, particularly because the first sketches don't need to be all that accurate, as long as you show the key points. So y equals e to the x, it's cutting at 1. The next one, we've changed x into 2x, and so that is a stretch, scale factor a half, x direction. So all that's happening is that this is coming in to halfway and halfway like that. So actually the sketch is going to look the same, and to all intents and purposes it's still cutting at 1. When we now do y equals e to the 2x plus 1, it all moves up 1. The important things here are not just where it cuts the y-axis, but also that you then need to show your asymptote. So for 1's moving up, it's going to cut the y-axis at 2, but also on these ones there was an asymptote on the x-axis, and you couldn't show that because of the axis being there. But as soon as you move it up 1, you can show that there is an asymptote at y equals 1. And you use this for the range, because the range is any value that the y could take, and you can see that y can be anything that's more than 1, so the range is y greater than 1. Notice it's greater than and not greater than or equal to, because the curve never actually touches the asymptote. The next one, we start with y equals ln x, which looks like this. We're trying to build up to ln 3x plus 4. So your next one is y equals ln 3x. Stretch, scale factor a third in the x-axis. So notice now, instead of it cutting the x-axis at 1, it's cutting the x-axis at a third. Then y equals 2 lots of that, so it's a stretch scale factor 2 in the y-axis. Effectively, it's going to look very much the same. It's still cutting at a third. That's the important bit. But now, If you look at the next bit where you add on 4, it's all going to move up 4. And so we need to be careful where is it going to cut the x-axis. It's not going to cut the y-axis at all. So x-axis is y equals 0. Y is 2 ln 3x plus 4. So 2 ln 3x plus 4 is 0. Rearrange it. 2 ln 3x is minus 4. Ln 3x is minus 2. 3x is e to the minus 2, so x is 1/3 of that, 1/3 e to the minus 2. So the important thing to show is that that is where it cuts the x-axis at 1/3 e to the minus 2. The range, well, the domain is restricted because x is always greater than 0, but the range, y can take any value, so the range is y is real numbers, y is in R. Next one, transformations. What transformations turn y equals e to the x into y equals e to 2x plus 7? Rearrange it first of all, move the 7 to the other side to get y minus 7 equals e to the 2x. Now compare with y equals e to the x. You'll see e to the x has turned into e to the 2x, so x has turned into 2x. And you'll see y has turned into y minus 7. So the two transformations, x to 2x, is a stretch, scale factor a half, parallel to the x-axis, or you could say in the x direction, y to y minus 7, translation by vector 0, 7, 0 plus 7. Because that is in the x direction and this is in the y direction, it doesn't matter about the order you do them in. Then finally, the harder equations. Now this just said ln of one part equals ln of another part. You could get rid of the ln's. But it says ln of 3x minus 2 add ln of x plus 2 equals the ln of 2x squared plus 12x minus 19. So you can't get rid of the ln's quite yet. But fortunately, we can combine these two using the rules of logs. So ln of 3x minus 2 add ln of x plus 2 is ln of their product, because when you add two logs, you multiply. And then that means that ln of 3x minus 2 times x plus 2 equals the ln of a 2x squared plus 12x minus 19. And as soon as you've got ln of something equals ln of something else, get rid of the logs. Now what you've got is a quadratic, or actually you've got one in x squared, another one of x squared is over here. So you expand both the left-hand side and then get everything equals to 0 to solve it, and you should get the answers x equals 3 or x equals 5. But the question is not quite at the end yet. You need to check those answers carefully. If, for instance, we put x as 3, go back to the original equation and see if it works. If we put x equals 3 in here, you get ln of 7 plus ln of 5 equals, and this comes to ln of 35, so that's fine. But if, for instance, we had got x as minus 3 as an answer here, and you tried putting that in, you would then get ln's of negative numbers, ln of minus 11, ln of minus 1. As soon as you see ln of a negative number, then it's not going to work. So always check the numbers back in and make sure that they actually work, but you're not got a ln of a negative number. Okay, so good luck with the review sheet.